Good evening, Fiveable. My name is Shane, and I am going to be walking you through AP Stats this year for Fiveable. Today, we're going to be focusing on displaying quantitative data with graphs. So let's dive into the first part. Think Fiveable. Go ahead and follow us on all these different platforms. These platforms are going to allow you to get updates on when people are going live, on what topics, and really just keep you informed about what we're doing here at Fiveable to help you pass the AP exam, save thousands of dollars in college, and be more confident stepping into those college classes. Here's kind of the scope and sequence of what we're going to be doing today. So I notice no one's in the stream. That's okay. I'm going to run through this agenda and this PowerPoint. This is a really, really important lesson because there's always one or two AP problems pre-response that has to do with something on this lesson. So make sure you're paying close attention. If you do pop in, ask any questions, shoot me email if you have a question as well. We'll make sure that you are prepared to enter the AP stat test. So we're going to start with constructing and interpret different forms of displaying quantitative variables. We have dot plots, we have stem plots, we have histograms. We're also going to describe the shape. This is the really, really important part, describing distributions. So that's going to be a really, really important thing for us moving forward. We also want to compare distributions. So when we compare distributions, we're really looking for specific language. We want to make sure that you know those specific languages. And last but not least, we want to know how to use histograms wisely. So making sure that we are using those histograms in an appropriate way. Let me see. Moving right along. Okay, so here we have our first data display, which is a dot plot. So a dot plot, each data value is shown as a dot above its location on a number line. So here I have some data. It's the number of goals scored per game by the 2004 US women's soccer team. So a whole bunch of data points. And as you can see, right above here, we have the number. So this would be 0 goals scored. This would be 1 goal scored. 2 goals scored. Now you don't see anything in between because you can't score 1.5 or 2.5 goals. So that's why you see the break in between. But you can see every single dot represents one game where X amount of goals were scored. So 1, 2, 3, 4, 5, it looks like 6. 6 games, we scored 2 or more goals, or the US women's soccer team scored 2 or more goals in 2004. Really, really easy. Works well for small data displays. Does not work great for really large data displays. How do we make a dot plot? So the first thing you do is you're going to draw a horizontal line, a number line, and label it with the variable's name. So if we go back, you can see we have that horizontal line drawn here. We labeled it 0, 1, 2, 4, 6, 8, all the way. And we labeled it with the context. It's going to be super important anytime you make a graphical display that you are labeling the variables on the X and Y axis. Y if we have 2 variables. But we really want to provide context to our reader. So we're going to draw that horizontal line. We're going to scale it from the minimum to the maximum value. So if we go back to our soccer goals, we obviously are not going to go into the negative because you can't score negative goals. But we're also not going to go past, let's say, 10, or in this case, 8. Right? It doesn't make sense to make my dot plot, the x-axis, go all the way to 100 because it's almost impossible to score 100 goals in a soccer game. And after that, you mark a dot above the location on the horizontal axis corresponding to each data value. So you just keep stacking up your data points as more and more data points take that value. All right, so we can clearly see that one game, the US women's team in 2004 scored 8 goals. We see that right here. one game they scored 7, and one game they scored 6. That's a dot plot. We also have what's called a stem plot. So stem plot is, it gives us a quick picture of the distribution while including the actual numerical values. So this is super important because it gives us the actual data points that we're working with. So if you look here, we have 2 stem plots. I'll talk about what the difference is, but we see here a key that tells us what it represents. Keys are going to be super important when you're creating stem plots. If you don't include a key for a stem plot, the AP exam will not give you full credit. You may have to create a stem plot from data on the free response part, but it hasn't been prominent. But you always need a key. So here the key tells us 2/2 represents a male student with 22 pairs of shoes. How do we make a stem plot? So we separate each observation into a stem, all but the final digit, and the leaf, which is the final digit. So here you can see we separated the stem right here, which is the tens digit, and the leaf right here, which is the 2, or the ones digit, I'm sorry. After that, we write all possible stems from the smallest to the largest in a vertical column and draw a line to the right of the column. So going back to our example, I write all the different stems, so 0, 1, 2, and 3. Those are all the tens digits for my data. Then I draw a line on the right-hand side. After that, I write each leaf into the row to the right of its stem, and then I arrange them from increasing order out of the stem. So I started writing all the data points to the right of my stem, creating my leaf, and I do it in increasing order. So it starts 4, then 5, then 6, then 7, then 8. Then you always provide a key that explains in context what the stem and leaves represent. So again, going back to our example, we have our key down here. We have 0, 4, which would represent a male student with 4 pairs of shoes. Now I don't need to include 4, 5, 6, 7, 8. I can stop at 3 because the highest data point I had was 38. So since there's nothing above that, I can just stop at 38, or stop at 3, I should say. Notice if there's no data in a certain point or in a certain row, we leave it blank and we still create it because that's going to show us some gaps that are going to be super important for us to discuss moving forward. We have 2 special types of stem plots. The first one is called a split stem plot. And it's best when data values are bunched up. It allows us to see the spread a little bit better. So what we do is we split our stems into 2 different stems. So instead of 0 being just one value and listing all the zeros here, I split them into 2. I put the 0 through 4 data points right here and the 5 through 9 right here. That's called a split stem plot. I'm sorry, I spelled it wrong there. Down here, we have back-to-back stem plots. Those allow us to compare distributions of the same quantity variable. So it allows us to look at our data and compare it with another set of data. So here we have males and females, the number of shoes that they have. So we can clearly see the difference and some key features of the males versus the females when we are describing data. All right, and notice it's still a split stem plot where we have the lower data values on the first one and the higher data values on the second one. Those are stem plots. The probably most important one and most common one is going to be what's called a histogram. So a histogram is quantitative variables often take many values. So a graph of a distribution may be clear if nearby values are grouped together. That's what we call a histogram. It's the most common graph of a distribution of one quantitative variable. Here is an example of a histogram. We have the daily sales in June. And for a histogram, you're always going to have frequency on the y-axis. So it's going to show how many times. Here's how you make a histogram. You divide the range of data into classes of equal width. So see these down here? These all have to be equal width. That's going to be really, really important to make a good histogram and to make something that's not misleading. We find the count or the frequency, or we can also do percent. So we can also do a relative frequency for our count of the individuals that fall into each class. So going back to our example, I can see that 2 days in June, the sale was $250. Looks like, yeah, $250. 4 days in June, the sale was somewhere between $250 and $255, it looks like. Right, so it gives us an interval. And then we need to label and scale your axes. We need to draw the histogram. And the height of the bars must go to the frequency. The key difference, one of the key differences between a histogram and a bar graph is that adjacent bars should touch unless there's nothing in that interval. So we want to make sure that these are touching. Unless for some reason there was no data here, then we wouldn't slide this over. We would just keep this area blank. Here's another example. On the bottom, we have percent of foreign-born residents. On the left-hand side, we have the number of states. So we can clearly see in our frequency table that 0 to 5% of foreign-born residents, 20 states have that proportion. So over here, between 0 and 5%, I have the bar going up to 20. Now, the downside to a histogram is it doesn't give us the exact data values. It just gives us an interval in which they could exist. So when it comes to histograms, you're not getting the exact data. You're just getting an interval in which it exists. We have 13 states that have between 5 and 10% of their residents foreign-born. And we can see that each bar goes to the corresponding height. So we have 9 states that have between 10 and 15% of their residents foreign-born, and so on all the way down until we get to 50. Using histograms wisely. So we really want to make sure that we're using those histograms wisely. We don't want to confuse histograms with bar graphs, which is why we have them close together, the bars. Don't use counts or percents as data. So you're not going to use 20 as a data point. That just tells you how many of this data point falls in that category. So don't use 20 as your data point. You wouldn't want to go to 20, put that there. Use percents instead of counts on the vertical axis when comparing distributions with different number of observations. So if we want to compare 2 data sets, but we didn't collect the same amount of data, we want to use percent instead of counts on the vertical axis, because that's going to give us a better idea of how they compare to each other. If I take a large data set in one, a small data set in another, of course there's going to be more data in the higher data set because we just collected more. So using percents kind of equals it out. And just because a graph looks nice, it's not necessarily a meaningful display of data. We really want to make sure that we're using the right data sets and the right data displays for each context. Now, before we get on, I am going to show you how to make some data displays on your calculator. So we're going to work on a histogram. We can't do stemplots and we can't do dotplots. But let's go on to our TI-84. So if you have a TI-84, now would be a good time to take it out. So working with calculators are going to save you a whole bunch of time on the AP exam. So here's how you make a graphical display. First thing you want to hit is the button Stat. So that button right there, you're going to hit Stat. Then you're going to go into Edit. So hit the button that says Enter. And you're going to see a bunch of lists. This is where you enter in all your data. I'm going to clear a list. To clear a list, you go to the top, you hit the Clear button. Don't hit Delete. Hit the Clear button. Hit Enter. And I'm going to type in the data that I had for the number of goals scored per game by the 2004 U.S. women's soccer team. So we had 3, 0. So you just type the number, hit Enter. 2, 7, 8, 2. You really want to make sure you're typing these in correct. Take your time. It's going to save you time if you do it right the first time. I have some students that just kind of push through, trying to get as fast as they can, but then they mess up, so they spend more time going through and trying to see which data point did I not enter in or which one did I do incorrectly. That can be really, really frustrating. Okay, so I have all my data in. To make the graphical display, you're going to hit the button that says Second, and you're going to go up here to Stat Plot. That's going to show you all the different plots that you can make. We're going to go into just the first plot. You want to make sure it's on. You're going to hit down. You want to select the correct data display. So for us, this is a scatter plot. We don't need that. We want the histogram right there. Hit Enter. Now you want to tell the calculator, hey, I'll graph this, but where is the data that you want me to graph? We put it in L2. If for some reason you put it somewhere else, see these blue buttons above the 4, 5, 6, 1, 2, 3? If you hit Second and that button, it'll put your list in there. Don't just hit 2, because that'll put the number 2 in there. You want list 2, or in this case, I want list 2. Frequency 1 is fine, and then you're going to hit graph. Uh-oh, I'm not seeing it. That's okay. The reason we're not seeing it is because we're not zoomed in on the correct spot on our graph. So anytime you want to zoom in on your graph, you hit zoom. See number 9, stat. So you can go down to number 9. You can also just hit the button 9, and it'll zoom in on your data set. That allows us to see the data as a histogram pretty quickly. You can also hit the button that says trace, and that'll tell you the count of that interval. So I had 6 games that scored between 1.33 goals and 2.66 goals. Really, for soccer, since they're discrete, that means you scored 2 goals in 6 games, 7 goals in 3 games, and so on. And there's those 1 goals that we scored in each of the other ones. You want to be very, very comfortable with your calculator. We'll do more calculator stuff moving forward, but just want to make sure that you're familiar because it is going to save you a lot of time. All right, let's go back to our PowerPoint. Let's see if I can find that. There it is. All right. When describing graphical displays, so when we describe graphical displays, it's going to be super important that you touch on 5 different things. In my class, in order for us to remember that, we use what's called CUSS, and we're BSERS. Some people probably know SOCS, S-O-C-S, but here we're going to use CUSS and BSERS. I'll show you why in a little bit. So when we describe a distribution, we want to hit on 5 different topics. The first, the C, represents center. So you want to talk about the center of a graphical display. For us, we want to use either mean or median. We also want to talk about unusual. So anything unusual about the graphical display, we want to talk about. That usually means gaps or outliers. Shape. We always want to talk about the shape of a distribution. Mostly we're using words like symmetrical, skewed, bimodal, uniform, all those. The next S represents spread. So what's the variability of our data? We use range, IQR, standard deviation. Any of those will work when talking about spread. So that represents the CUSS part. The BS part, the BS, you always need to be specific. So write about the context. What is the problem talking about? What is it representing? U.S. women's soccer team goals by game in the 2004 Olympics. That's context. You want to bring that in one time when you're writing your responses on the AP exam. And the ER part comes in if you are comparing exams or comparing graphical displays. So if they want you to compare, I think earlier we looked at the amount of shoes that students who identify as male have versus the amount of shoes that students who identify female has. So if we were to compare those two, we'd want to use ER words. Like the center is smaller for the students who identify as males than the students who identify as females, right? We really want to use ER words when we're describing 2 distributions. All right, so let's talk more about center. We can describe the center by finding a value that divides the observations so that about half take larger and about half take smaller values. 2 ways to describe center. We could do the median. The median works best when distributions are skewed. So if you have a skewed distribution, you're going to want to hit the median. When we have symmetrical, our mean is the best measure of center. So when we're doing symmetrical data, the mean is a really good way to measure center. The U. So the U represents unusual features in our graphical display. Now, a lot of the times we're talking about outliers. Outliers are values that differ from the overall pattern. We call them outliers. We will learn specifically how to identify an outlier, but for right now, we can say a potential outlier. There is a rule that tells us how far away a data point must be from the other data points in order for us to call it an outlier. But we can always use potential outlier if we're not sure or if we can't calculate it. Gaps. We also want to talk about gaps. So any area that doesn't have any data. We really want to make sure that we're pointing that out when we're describing our distributions on the AP exam. So over here you can see we have some data points. We have a potential outlier all the way over there at 15. So outliers are going to help us talk about, or outliers and gaps are something we need to talk about when we're describing a distribution. So center, unusual, next comes shape. So when we describe shape, we're looking for the main features. We want to look for symmetry or clear skewness. So looking at this graphical display below, we see symmetry. It's very, very symmetrical. Perfectly symmetrical, actually. You're very rarely going to get that in real data. This is what you're most likely going to get when looking at real data. If the right and left sides of the graph are approximately mirror images of each other, we call that symmetrical. Statisticians really, really like symmetrical data. It's very, very interesting and allows us to do some great calculations. So symmetric is one way to describe the shape of a distribution, and symmetric occurs when the right and left sides of graphs are approximately mirror images. We also have what's called skewed to the right. Right skewed or positively skewed is sometimes how it's referred. If the right side of the graph is much longer than the left side of the graph, we call it skewed to the right. You can also think about where is the tail. So if I were to draw kind of like a little line above it, where does the tail go? So the tail goes to the right here. So we call it skewed to the right. On the opposite, we have skewed to the left. We call it left skewed or negative skewed. If the left side of the graph is much longer than the right side, we call it skewed to the left. Same idea. If I were to draw a line above my data set, you could kind of see the tail going to the left. So we call that left skewed or skewed to the left. Other ways to describe shape: unimodal just means one peak. Bimodal means two peaks. And anything above bimodal we call multimodal. So it's got a lot of different peaks. Spread. So the last S of CUSS is called spread. The spread of a distribution tells us how much variability there is in the data. Got to work on that typo. So spread tells us where the data is in relationship to the other data. Ways we describe spread: we can calculate the range, which is the maximum minus the minimum. We can calculate the IQR, also known as inner quartile range. That's going to be your Q3 minus your Q1. That's going to tell you how spread out is the inner 50% of our data. The range is going to give you all the data. How spread out is all your data. IQR is going to give you your middle 50%. Standard deviation is also a way to measure spread. It's a really popular way to measure spread. Here's how we calculate it. You take the square root of the sum of each data point minus the average squared divided by the total number of data points. We'll dive more into standard deviation on our next stream, but for now, standard deviation is one way we can measure spread. So below, we have a distribution of MPGs achieved by various Honda vehicles. We want to describe the center, the shape, the spread of the distribution, talk about any outliers, and remember to include context. So let's go through our CUSS. First, the C, center. We want to look at where the center of the distribution would be. So because this is a dot plot, we actually could find the median pretty quickly. We would just count up the total number of dots, divided by 2. Whatever data point is X data point, that would give us the median. Unusual. So the median is probably going to be somewhere around 28, 27. You can kind of see half the data point is below and half the data point is above. Unusual. Is there anything unusual? Yeah, there's 2 data points that might be potential outliers. One car that got 14 miles per the gallon and one car that got 18 miles per gallon. So we want to mention that, hey, there might be some potential outliers down on the low end at 14 and 18. So we talked about center, we talked about unusual. Now we want to talk about shape. And I would say this is skewed to the left. Remember the tail. Where is the tail of your data? It's going to be down here. Tail of our data. So we can say skewed to the left. And our last one is the spread. So how spread out is this data? Well, the range, maximum minus minimum, is going to be 33 minus 14, which is going to give me 19. So the range is 19. Now, at some point when talking about those 4 items, I needed to talk about the context. Now, context just means you mention what the data is about. So maybe I could say the center of the distribution of MPGs achieved by various Honda vehicles is around 27. That right there gives me context for the whole problem. So I don't need to bring up context again. I just need to say it one time. On the AP exam, they're going to make sure that you give them context to get full credit. What I tell my students is you can use what's called the stem of the problem. So it'll tell you the context in the problem. Right here it says the distribution of MPG achieved by various Honda vehicles. That right there is the stem. Take that out, put it in your answer, and you'll get context. We talked about CUSS, we talked about BS. The ER doesn't really apply here because we're not comparing distributions. We're just looking at one distribution. So let me show you what I got. The shape is roughly unimodal. There's one peak and skewed to the left, like we talked about, right? Skewed to the left. The left side brings down the data. The center is about 25.9. That's the mean. And the median is about 28. But we only need to talk about one measure. So I talked about the median being around 27, 28, same idea. Spread. The spread or the range is 19 miles per gallon. High minus low. Max minus min. And outliers. There are 2 potential outliers or influential points, 14 and 18. And at some point, again, we just want to make sure we talk about the context of the problem. If you do all that, you'll get full credit on the AP exam. Okay, so hopefully you learned a little bit about the types of graphical displays that we use, how we describe them, to make sure that you get full credit on the AP exam. Go ahead and make sure you follow us at Think5able on all of our social media platforms. That'll give you a great idea of when we're going live with what subjects. Go ahead and if you liked this video, make sure you share Fiveable with your friends. We're trying to get as many high school students to pass the AP exam at the end of the year, and it really helps having people in the streams to ask questions so that we can kind of guide our experience for your learning. Thanks again, and I'll be back next week with more AP stats.